it do? What it do? What's going on, family? You've now tuned into the network, bro. And let me see if I can get my webcam going here. Webcam PNG. Microphone check. Y'all let me know if y'all can hear me in the chat. I got my snowball mic connected this time. I listened to the stream yesterday, and the sound was not as good as I thought it should be. And today we're going to be doing Eigrp routes. Yes, more Eigrp. We're going to be using Boson Netsim again. This should be a really simple lab. There's going to be a second lab too, I guess, depending on how long it takes for us to do this. As you can see, there's only 2 routers here. Let me copy this and put this in. I want to put this in Paint. Y'all know I like to do my annotations and stuff while I try to get this going. Paint. That should be good enough. That should be good enough. This is a quick little lab here. Again, this is in the ENARSI section of the Boson Netsim application, right? Yesterday we did the Eigrp lab. Today we're doing Eigrp routes, and we got time. We'll do both these labs right here that I got in the green check mark right there. Yes, I did a little quick run through for them, so we should be able to run through it as well on this stream here. We got Lavaris in the building. Hit that like button. Yeah, hit that like button. Appreciate you for tuning in. We got D Brown in the building. Been a while since I tuned in. You grew your hair out. Yes, it's been that long. I grew my hair out, man. I could actually braid it and twist it and everything, man. But yeah, it's been a minute since I've been streaming. Just to give you guys an update, I made an attempt at the ENARSI exam and I failed it. I don't know what the score was, because they don't give you a cumulative score anymore. They just give you a breakdown of like 4 categories, and they tell you like 1 out of 50 or 1 out of 100 for each of those. I guess you could take all 4 of those scores and get an average. That'll give you a cumulative score that way. But it's no longer what they used to do with like a grading scale of like, I think 0 to 900 or something like that back in the day. They don't do that no more. So I guess you got to kind of figure out your own score. But yeah, again, if you're just tuning in, we're going to be doing just 2 quick labs here while you guys are getting, hopefully you got a copy of this application. If not, then you might have to build this lab on your own. But that's the topology. If you have, EvenG or GNS3 or Packet Tracer, you can build this on your own as well. But if you have Boson Netsim, this lab is already built for you. So you just got to punch in some calculations or some commands and run through it real quick. So yeah, 2 routers. It's a real simple network. I was gonna read this quick article for y'all, and then we'll jump right into it. Attackers can force Amazon Echoes to hack themselves with self-issued commands. Craziness, right? Popular smart device follows commands issued by its own speaker. What could go wrong, right? So like, I guess if you have 2 Amazon Echoes, or maybe a Alexa and an Amazon Echo. Well, the Amazon Echo is Alexa, right? Am I saying that right? Well, anyways, you have 2 of those devices, have them talking to each other, giving each other commands, I guess, and you can kind of hack it that way. Academic researchers have devised a new working exploit that commandeers Amazon Echo smart speakers and forces them to unlock doors, make phone calls and unauthorized purchases, and control furnaces, microwave ovens, and other smart appliances. The more smart devices we have, the more like exploits you have in your home. Everything is that's why they call it the IoT, right? Internet of Things. Everything is being put on the internet. Refrigerators, microwaves, your car, everything is being put on the internet. But as we all know, all of those devices can get exploited. This is one example of that. The attack works by using the device's speaker to issue voice commands. As long as the speech contains the device wake word, usually Alexa or Echo, followed by a permissible command, the Echo will carry it out. Researchers from Royal Holloway University in London, Italy's University of Catania found, even when devices require verbal confirmation before executing sensitive commands, it's trivial to bypass the measure by adding the word yes about 6 seconds after issuing the command. Attackers can also exploit what the researchers call the FW, or full voice vulnerability, which allows echoes to make self-issued commands without temporarily reducing the device volume. Alexa, go hack yourself. Can you imagine, man? Like, it'll be like, y'all ever seen that movie Mitchell's versus the Machines, where like all of these devices that are like pretty much controlled by IP and just the internet, right? These devices, like the refrigerators, start walking on. I have a 7-year-old daughter, so yeah, I'm forced to watch these cartoon movies and stuff like that. But it's a really good movie when you watch it. Great writer, great storyline. But Mitchell's versus Machines, y'all got to see that. This is what like the world could come to if things go awry. I'm not gonna read the whole article. D Brown said, "I'll never rely on that stuff." Me too. I'm just old school. Same here, man. Like I don't have smart windows. I use a regular door lock, a deadbolt. I don't have a smart camera or like what do you call those cameras at the doorbell? They're just called a bell or just a door. Yeah, that's creepy. Agreed. I saw an article a while ago who were able to use laser pointer and pointing at the microphone of an Amazon Alexa to execute commands. Seriously, that's crazy, man. Using a laser pointer, pointing at the microphone. How the hell do they do that, man? Anything could be hacked, man. That's why I said, man, these hackers, if they could just use their talent to instead of using them for nefarious purposes, man, they could, like, we would have the cure for cancer right about now. Anyway, let's go ahead and get started. Eigrp Routes Lab. As you can see, there's only 2 devices here, so we should be able to run through this real quick. Learn the commands needed to test an Eigrp configuration. Where are the steps? There's the instructions right there. Let me make it a little smaller. Zoom out some because I was trying to take a picture of that. As you can see, we got some basic commands. Where's my camera over there? Yeah, okay. I just want to make sure that I don't cover myself. And let's cover this up out of the way because that took up some room. Get that out of the way. That takes up some room. So now y'all can see the command line. We are in router. I think you got to rename them. That's why. We got some basic commands here, including, they're just basic commands. Nothing really Eigrp related there. Here's the 6 tasks we got to do, and then we'll run through it. And we got the solutions at the bottom. Configure router 1 with the appropriate host name, who's this guy right over here. Right now, he's just labeled. When you get it out the box, it just says router, right? You got to change the host name. Configure the appropriate IP addresses on the interfaces. Refer to the IP addressing table, which is right here. A DCE cable is connected to router 1. The serial link should have a speed of 64 kilobits per second. Enable the interfaces. That should be easy. If you don't know how to do that, just follow along, right? We're going to enable mode, global config mode. We said we want to give them the host name of router 1. So router 1. They said give them the appropriate IP addressing and then enable the interfaces. So turn them up, right? We got FA01 with that IP address, 000 with that IP address. And we got to do the same thing on router 2, right? Real easy lab. Interface FA0, 0/0. What am I doing? Did I name them router yet? Yes, I did. Oh, what? Okay, so IP address. Jeez, I'm not even on the interface yet. FA00. IP address is 192.168.101.1. I gotta clean this keyboard, man. Freaking dog spilled wine, like wine coolers all over it. So luckily it still worked, but the fingerprinter don't work no more. So this keyboard is just feels weird, man. I gotta open it up and fix it. Subnet master /24. Y'all got any questions so far or anything? Turn up the interface. I hope I did that right so far. No shut. They said we need to set the clock rate on the serial interface. I believe that's on router 1, right? Yes. So let's go to the serial interface, which is interface serial 00, IP address of 192.168.1.1. Subnet mask of 255.255.255.0. No shut that bad boy. Well, let's give them the clock rate command. Clock. If you don't know how to convert, you could just clock rate question mark and you see the possible options, right? This is bits per second. They said 64. What they said? 64 kilobits per second. What is that in here? Well, there's only one of them that start with a 64, so it's that guy right there. 64. You could just tab over, press enter. That's 64 kilobits per second. I backed out of it. Let's go back into it. Serial 00, because right now, if you can see, show IP interface brief, it's still admin down. Remember, because when you get a router, get it out the box, the serial and the interfaces are always shut down, so you have to enable it, right? Go back to global config mode, interface serial 00. Oops, 00. Come on, man. I hate the way this keyboard feels now, man. No shut. That brings him up. It's probably gonna go back down because that side is down, right? Right, because we turned this side up. Boop. That side is up, but this side right here is still down. So that interface, so that means this connection is down. We have to have both of them for this interface to be up. That simulates the wide area network. So right now, that's why it went up and then went back down, because it's like, oh, there's nothing on the other side there. So I think we should be done with router 1. Let's move on to router 2 and do those interfaces. So we need to move on to this router right here. Y'all got any questions so far? We got Professor Black Ops in the building. Appreciate you for tuning in. The Ring doorbell, Kobe. That's what I was looking for. Yeah, man. Like, y'all watch that movie, Mitchell's vs. Machines, where basically all these Internet of Things devices, not even just Internet of Things, just everything like that's remotely that gets on the internet can just come alive. Like, there's refrigerators and toasters is walking at them, and it's a good movie, man. I know it's a cartoon, but you know, it was a really good storyline. Professor Black Ops with the stick of the day looks like configure Cisco switch protect. Wait. Configuring the Cisco switch protects against known types of DOS attacks or denial of service attacks on the route processor. Implementing a COPP policy is a best practice method. Yes, COPP stands for, what was that? Control something policy. It's a way to protect the control plane, right? We got the data plane and the control plane. Control plane is all the functions that controls the device itself, and not just the data, but the controlling the device itself. So SSH traffic, telnet traffic, whatever. When we implement COPP, it's like he said, it's a best practice method. So that's a way to secure our devices by turning on or enabling COPP on a router or switch. But today we're working on Eigrp routes. What we need to go on router 2, which is that guy right there. Get back into the topology. That's router 2, and we need to change his name to router 2. Go to global config mode. Router. Yeah, so Professor Black Ops, I was reading an article about how they found exploits with Amazon Echoes and Alexa and stuff like that. You could have them basically talk to each other and find an exploit. Academic researchers have devised a new working exploit that commandeers Amazon Echo Smart speakers and forces them to unlock doors, make phone calls and unauthorized purchases, and control furnaces, microwave ovens, and other smart appliances. And what was it? Who said that? Was it Lavarius? Said that D. Brown said that he saw an article they saw that they were able to control the Amazon Echo with a laser pointer. So it's just crazy, man. His name is Router, host name, Router, capital R, Router 2. We were going to give him the IP addresses. Where was it? Here's the instructions right there. Fast Ethernet 00, FA00. We should be able to run through this lab. It's a real easy lab, man. I know this is an NARSI section of the application, but this is one of the first labs that was in there. So if you're wondering why are we doing this easy shit, man, if one of the an RC lab, his IP address is 192.2.168.100.1, right? You see that right there? 100.1. So 100.1. Subnet mask of 255.255.255.0.0. No shut that bad boy. That is the local interface. We did this side right here. Now we need to turn up that side, and we should see that interface come up, right? Interface serial 00, and we said we're gonna give him the IP address of this right here, 192.168.1.2/24, right? So IP address 192.168.1.2. Is that what I said? Yep. subnet mask 255.255.0. Shut that bad boy. That should bring the other side up. So that brings him up, and we should bring that side up too. So if we go back over there, see now that side is up too. So now we just turned up this side, right? That came up, and then this interface came up. My fucked up arrow there. Y'all got any questions so far? Facts. IoT devices are vulnerable. Smart speaker can control at a high decibel where humans can't hear. That's just craziness, man. Y'all watch that movie, Mitchell's vs. Machines, man. It's just crazy how, I don't want to give it away. I don't want to spoiler alert, but basically the phone just took over the damn world, man. I like that movie, man. I really like that movie. But yeah, so we turned up that both sides. What is the next step they wanted us to do here? Enable the interfaces. On router 1, display the routing table and review the routes displayed. Note that only the routes displayed are the ones that are only directly connected. So we go to router 1, right? We're in router 1 already. And we display the routing table with the command show IP routes, right? Notice we have, this is how you dissect the routing table, right? First they give you the codes, right? These are basically like a legend of what these letters mean, what the hell all this shit right here mean, right? And then this tells you what the default route is right here. Right now, the default route is not set, as it says in plain English. Gateway of last resort is not set. Basically, it's saying, if we have some unknown traffic, what do we do with it? Well, I don't know, because we don't have a gateway of last resort. And then we have VCs, which means connected routes, and the Ls means local. What's the difference between the two? I'll show you. The C's are routes that are connected to us. So, obviously, right? Duh, NetworkBruh, network duh, right? The routes that are connected to us. So we're connected to the, I know it says 192.168.1.1, but this is the 1.0 network right here. This is the 1.0 network. We're connected to it, right? But the L means it's locally on this router, right? When we're looking at router 1's vantage point. So what's locally on this router? 192.168.101.1, right? So where is it? 1.1 is locally configured on this router. But the C, that's how I remember it. The C is the network of 1.0. This is the 1.0 network, but the 1.1 is locally on this router. That's the difference between a connected route and a local route, right? It's not really a local route. It's more like a local interface, if that makes any sense. But we do have a route to that interface, I guess. I don't know a better way to explain it, but that's the difference between the C and the L, right? Well, what about these networks over here, right? So we said we got the 1.0 network. What else we got? A 101.0 network. 1.0 network, which is down here, is the 1.0 network. But what about this right here? This is the 100.0 network. Does he have a way to get there? No, we don't have we have the 101.0, which is over here. This is the 101.0 network. But what about, how do we get to the 100.0 network, right? That's where Eigrp comes in. It gives us a way to get to remote networks that are not directly connected to us. So if we're looking at router 1, this router 1 right here, right? He knows how to get to this network right here. But this sits behind router 2. We don't know how to get over there. We don't know how to get over there until router 2 tells us. We don't know how to get to this network over here until router 2 tells us, right? Well, we can have him tell us with either a static route or what we're learning today, Eigrp. So let's go ahead and do that. Professor Blackout said, I'm finishing up medical devices being hacked video. Pacemakers and insulin pumps. Oh, God. Can you imagine, man? They hacking. Oh. Well, they are doing that. They've been. I used to work for the hospital system where, ransomware attacks, and they hold their information and data, at ransom, and force these hospitals to displace their patients to other hospitals and reroute. Didn't there something like that happen in California where they had to just displace a whole bunch of patients because basically the system got hacked with ransomware? And yeah, man, it's just That's why cybersecurity is a hot field, man. There's just so much crime. Look what's going on in Russia and Ukraine. We damn near taking a whole nation using cyber warfare, man. It's crazy. So, you know, if you can get into cybersecurity, man, hot field, man. Let's go ahead and have router 2 tell us about these networks here. How are we going to do that? With EIGRP. Configure router 1 and router 2 with EIGRP so that all devices can ping any other device. Use autonomous system AS number 10, specify the wildcard mask for each network advertised. So we're going to have router 2. Router 2 is going to tell router 1 about this network back here. And in router, vice versa, router 1 is going to tell router 2 about this network back here. They don't know about each other's remote networks, right? And that's where EIGRP comes in. So let's go to router 1 and global config mode. We said router EIGRP AS number 10. We're going to have router 1. Let me show y'all real quick. We're going to have router 1 tell router 2 about the network that sits back here. Because remember, he don't know about that network. Just like router 1 don't know about the network back here. That's how they're going to know about each other's remote networks, right? We're going to have router 1 tell him about the 101.0 network /24. How do we do that? With a network statement. 192.168.101.0 network. Oops. Yeah, 101.0 network. And subnet mask of /24. But we're not going to do subnet mask. We're going to use, they said wildcard mask, right? Yeah, they said use the correct wildcard mask, right? Which is the inverse of a subnet mask. So 0.0.0.255. They didn't say anything about auto summarizing. There's only one network anyway. Let's do the same thing on router 2. Go to router 2. Once we do this, we should see EIGRP, a neighbor relationship come up between the two. Exit router EIGRP 10 and have router 2. This guy right here, tell router 1 about this network right here, which is the 100.0 network, right? This guy told him about the 101.0 network, and now he's going to tell the other guy about 100.0 network, right? I hope that makes sense. Y'all just ask away if y'all got any questions. D. Brown said, ransomware is some BS. The company I worked for got hacked, man. The last couple companies I worked for got hacked. I worked for an MSP who did contracts with a medical company. I'm not going to say who, but they got hacked with ransomware. It turned into a fiasco. At one point, we weren't sure if we were going to have jobs. That's the thing about cybersecurity. You be the first one to get blamed if there's a hack. You know what I mean? The basic of cybersecurity is networking. You got to control path, direction, encryption, protocols, and ports. Cisco is the big dog. Exactly. And that's why I just love the fundamentals of networking and how things work. You know, eventually I think I want to specialize in security, but I just love the basics and how to manipulate traffic and how to, you know, like EIGRP, sharing routes and stuff like that. D. Brown, cyber streets are dangerous. Yes, they are, man. Facts. So network 192.168.100. Oops, I put 169. Watch your typos there. 100.0. No. Yes, 100.0 network. Subnet mask of 0.0.0.255. I believe I should be correct with that in saying that. We should see a neighbor relationship come up. If not, then we need another network statement. So we told each other about the remote networks, but we didn't add. This is the reason why we didn't put in. We don't got a neighbor relationship yet. I'll show y'all. We basically put that interface in EIGRP. We put that interface in EIGRP. But in order for these two relationship to become have an EIGRP relationship and be smiley, right? With our as a relationship should be, right? We need to put that interface to participate in EIGRP and this interface to participate, say that 5 times in a row, participate in EIGRP. Then we should have know each other's routes and how to get there, even though they're directly connected. But in order for them to participate in EIGRP, we need to have some sort of relationship between the two, right? So let's put the 1.0 network on both sides, right? This is the 1.0, the other one's 1.0. I guess what I could have done was just 192.168.0.0. That would have put all of the networks in it, but whatever. Let's put 2 network statements. Let's see how they wanted us to really do it. Let's see. What did it say here? Let me go back and take a look. Note that only routes are displayed. Yeah, I think we should be good. The solution's at the bottom in case we don't, get this right, and we can push Control G and it'll grade the lab. That's what I love about Boson Netsim. Which, by the way, if you guys haven't seen yesterday's stream, I gave away a free, was it yesterday? Yeah, it might have been yesterday. A free copy of this application for reaching the 5,000 subscribers. So I appreciate you guys for tuning in. Make sure y'all hit that like button on your way out and everything like that too. So I appreciate all of you guys subscribing and watching my channel and stuff. So 192.168.1.0 network, and then /24. 255. Remember, that's a subnet mask. I guess I could have just done 0.0. I could have done that. Let's put him also participate in EIGRP. Now we put that interface in EIGRP. Now I got to do this one right here, right? Y'all with me so far? 192.168.1.0 0.0.255. And if we did this correctly, we should see a neighbor relationship pop up. There we go, right there. We got a new adjacency, right? Number change. We got the dual algorithm. This is a level 5 message. It says, who's my neighbor? 1.2. Who's that? 1.2 is this guy right here, right? 1.2. See that? And now we have a neighbor relationship between both of these routers. So theoretically, we should be able to ping from host A to host B, right? Now that they know each other's remote networks, right? What else did they want us to do before we move on to do that? Verify, on router 1, display the routing table and review the routes displayed. Note that the routes displayed are both we did this already, and the route advertised by router 2. Oh, we did this part right here where we only saw the directly connected routes. Now we should see an EIGRP route. Remember what the routing table looked like before? We only saw the C connected route and the local route. But now if we do a show IP route, we have a D right there, right? What does that stand for? That stands for, if we look at our legend here, D stands for EIGRP. So we learned about an EIGRP route. What is that EIGRP route? It takes us to the 100.0 network, right? This is from router 1. What's the 100.0 network? That sits back here. So now he know about that network, and that's how host A should be able to ping host B. So let's go to host A, right, and get all this scribbler out the way. Let's see if this guy, host A, can ping host B, which is 100. I don't know what host B's IP address is. It's probably 1.10. I don't know. Let's see. Let's look at the addressing guide. It tells us host B is 100.2. 192.168.100.2. So go to host A, ping 192.168.100.2. Get on our knees, pray to the network gods, and we got a reply. Y'all make sure y'all hit that like button. D Brown said, one thing that companies fail to do is put more money in the budget for security. Hey, if they can skimp on IT or anything like that and put money on elsewhere, they will do so. When security should be, at the forefront of their priorities. That was the reason why my company got hacked. We would let them know that our systems aren't secure, but they didn't care. Not until it happened. Then it became a priority. Yeah, where I work at currently, I work in the education sector, which, by the way, we actually hired a cybersecurity firm to basically hack our systems, right? What they call it? What they call it? White hat or red team or blue team? I don't remember the difference between the two. But anyways, we hired a third-party cybersecurity firm, found the holes on our network, and I'm in charge of the layer 2 portion of the network, and they was able to get, I don't want to say what the vulnerabilities were, but one of the strongest points we had, I don't even want to say what that is either, but anyways, we hired this cybersecurity firm. They found all of our exploits or all of our holes in on our network, and they basically gave us this huge PDF guide and said, "Look, these are the problems. These are how you fix it." And that's what a lot of companies should do, man. Just fire these. If you don't know what's wrong, or if your internal systems or your internal engineers are saying, "Here's what's wrong," or if you don't have a big team, hire a third-party firm and tell us, "Hey, what's wrong with our network? We'll fix it once you find what is wrong with it." So pen testing and red team. There we go. Professor Black Ops. He always comes through when it comes to security stuff, man. But yeah, that's basically what they did. They hacked into our networks and said, "Here's what's wrong, and here's how we were able to break into y'all shit." So, but we was able to get host A ping host B. If you don't know what's wrong, or if you found out you couldn't ping, or the shit didn't go across right, you could just go to the lab function right here, grade lab, or press Control G and see where we missed, and see if we push Control G, it says here we could complete the lab successfully. So we're good to go. Took us, I guess, 25 minutes to finish that lab. Let's move on to the second lab if y'all want to do that, or we could just call it a stream. Usually I stream for about an hour, and then but I knew we was gonna run through this one. This is a really small lab. So the next lab was no, not that one. You got a view, Windows, labs. Where'd that window go? There you go. We already did not CCNA, but the ENARSI labs, Eigrp and Wildcard masks. So we're gonna load that lab. Y'all got any questions on that last lab? Real simple lab, right? Should be easy. This one should be easy too. We just got to work with wildcard masks. With this one, let's close this bad boy. Even though I made this a little bit bigger, I still didn't see it on the stream. Y'all let me know how the sound is, man. I got this snowball mic. Shout out to my man Patrick Canane, who actually donated this. He's another YouTuber. He specializes in CCNA, more like collaboration stuff. So voice, video, and stuff like that. I'd love to see your BGP labs, because I'm trying to figure out disaster recovery solutions via BGP. Yeah, there's tons of them. I don't make all of these labs up. Sometimes I'll do what's called Freestyle Fridays, where we just build a lab from scratch and work with these different technologies, where we'll mix BGP with OSPF or whatever. But a lot of times when it comes to these labs, streaming and stuff like that on my LiveLabs, I get these pre-built labs and kind of go over it and explain it. And if I get anything wrong, ask away in the chat. And I learn from you guys, vice versa. So federal systems have a professional red team. Have to have a professional red team, like you're saying, and pen test every 3 years. Didn't know that. They get access to internal conference room and attack from inside the network. That's crazy. Yeah. So sound is good. Okay, cool. Thank you, Kobe. But yeah, I didn't know that every 3 years I guess, what did they get, like they get like a certification, or do they just get like what sort of stamp of approval is it that they get? I know that when is it like DOD 2 or something like that? When they're like following STIGs and stuff like that, what sort of stamp or certification do they get? Like, let's say if a school is following all of these STIGs guide, what sort of stamp of approval do they get? Like in law enforcement, they have like accreditation and stuff like that, right? What do they have for if they follow, like, I guess, STIG rules and stuff? This lab right here is also an Eigrp lab. Let's pull up this right here. Understanding wildcard masks, and use wildcard masks to specify which interfaces Eigrp should use. Eigrp routers maintain a neighbor table and a topology table. The neighbor table lists all the adjacent routers. Blah, 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 right? We said Eigrp is a routing protocol that's used to share routes, right? So if this router doesn't know about remote networks from the other one, he shares with everybody else using a protocol called Eigrp. And that's basically what a protocol is. It's a language. It's a set of rules that we use to advertise routes to another router. And it is Cisco proprietary In other words, Cisco invented it, and then and I think in like 2013 they kind of was like, okay, you other companies, y'all can use it too, and it became what's called open source. So you can use Eigrp on any brand router at this in this day and age. What else we want to say? This topology we're going to be working with. Let's zoom in, take a snapshot of that with my favorite application, Microsoft Paint. So that way I can do my annotations and stuff. Y'all give me a couple seconds here. I doubt you guys will be able to build this from scratch right now because we're doing this on the fly. But if you have Boson Netsim, feel free to follow along. If you were a loyal subscriber to this channel, you would have got the free giveaway of this application. The good folks at Boson gave me a free copy of this application to demonstrate on my channel, and I actually gave away a copy of this. So if you'd have known about this channel, you'd have got your free copy. Shout out to, I think his name was Prentice Adair. I haven't heard from him yet. He was the winner of the giveaway. So that should be good enough right there. Still waiting to hear on him. I don't know how long I'm gonna give him, but it took last time I did a giveaway on my channel, it took a couple days before the winner hit me up. What do they want to say here? How many steps we got on this one? These are a couple basic commands that we know about. Configure terminal, right? Enable command. We got ping, basic show commands here. We are in Florida, as you can see here. So am I. In case y'all don't know, I'm in Orlando. We got Daytona, Key West, Miami, Orlando, Tampa, right? Respectively. So this is going to simulate the wide area network right here. We have the local area network right here, which is Key West. And here's the remote networks that we have these local area networks on that side of the router, right? In order for them to know about it, we're going to use the routing protocol, Eigrp, right? So what is the... Let me close this right here. Bloop. What's the first step they want us to do here? Here's our lab tasks. The routers have been configured with admin as the password at the console prompts, Cisco as the password at the enable prompts, and San Fran at the VTY password. Task 1, examine the initial network config. How many tasks we got? We got 1, 2, 3, and then we should be done. Right? 3 tasks with several subtasks in the middle, right? Verify routing. On Key West, display the contents of the routing table. How do we do that? Show IP route, right? So we go to the Key West router, which is right over here. I'm fucking it all up right here. Fuck it up, fuck it up, fuck it up. They said the password was admin, ADMIN, if I can spell. Enable password was Cisco. Please do not use that as your passwords or you'll definitely fail the STIG implementation guide. Professor Blackops said, federal auditors come on site every 3 years to give you an authority to operate certification for DoD systems. If you fail, your system could be shut down. Wow, that's crazy. We need to do a re-roll. We should, right? So you get an authority to operate certification for DoD systems. That's crazy. Okay, that's cool. Yep. So that's the certification they get. And if they fail, their system could be shut down. What about the companies or the organizations that, remember a couple months ago, several organizations in the federal government got like a grade of C and D, and a lot of them kind of not necessarily failed, but they did not get an A. Do they still get the certification? Because there was an article, remember I read a couple months back where I don't remember if it was not the Pentagon, but some organizations that are part of the federal government got a grade of C. Do they still get the certification? That's my question. So we're in the Key West router. They said to display the routing table. We do that with show IP route. As you can see, we got several D's here, which stands for, we look at the routing table, it says here, or the legends, that the D stands for Eigrp, right? So we've got several Eigrp routes here, We got the L, which means it's locally configured. Just remember that as being an interface that is on our router. So we got 5.1 and 100.18 should be 2 interfaces on our router, right? Let's see. We do show IP interface brief. That'll let us know. Show IP interface brief, right? 5.1, 100.18. Sure enough, right? That's how I used to get confused. What the fuck is the difference between the C and the L? Like, they're both on here. Why do we have routes to them? Well, one of them, the C, means it's a route that we know about, and then the L means it's locally configured. It is an interface that is on our router. That is what the difference between the two is, right? And then the D's are the remote networks, remotes that are not directly connected to us, right? But it also could be a B, or it also could be an O, remote networks. We learned from other routing protocols, right? What are they? They're right in here in the codes, but that's for another day. What else they wanted us to know? Refer to the network topology diagram and Key West's routing table. Are all networks shown in a topology diagram listed as either directly connected routes or EIGRP routes? Well, I just told y'all, right? We have a directly connected route with the C. We have the L for local routes, and all these D's let us know they're EIGRP routes, right? We look at the routing, the addressing guide, and it tells us we have routes to pretty much all of them, right? Right? You have any questions or anything so far? We got Anderson Tech Repair in the building. Welcome back. Appreciate you for tuning in, man. I know it's been a minute since I streamed. You see my hair done grew out, man. I cut my beard, but just to give you an update, I took the NRC exam. I made an attempt and I failed it. I don't know how many points or anything like that. They don't give you a cumulative score, but if I was to take a guess, it was like somewhere in the 70 range. But I said I'm gonna start streaming again, and I'm gonna make another attempt pretty soon. If you missed yesterday's lab or yesterday's stream, I did a giveaway. Make sure you hit that like button too, and subscribe to this channel if this is your first time, watching. But I gave away a copy of this application, Boson Netsim. I'm still waiting to hear from the winner. And I think he picked the CCNP version of this. So still waiting on Prentice Adair. Shout out to Prentice Adair for winning that. What else they want us to know? So we already verified routing, verify connectivity from host E, attempt to ping host A. So from host E, where's he at? Host E, they want us to ping host A, which sits back here. So basically they want us to send a ping from all the way over, as you can see, right? From here to there, right? We should be able to be in that. If our routing table is full and is complete, we should be able to ping him. What is host B's IP address? It's right there. It says it right there. 192.168.2.2. Let's see if we can ping it from host E. So let's go to host E, right? And he said ping 192.168.1. Oops, I got a 2 there. Made a mistake. 192.168.1.2. Is that what I said? 2.2. 2.2. Press enter. Wait for it. We got a reply. We got a couple replies there. So we're good to go. We got connectivity. Are these pings successful? Yes, they are. Task 2. We're already on task 2. There's only 3 tasks. We running through this. Implement EIGRP wildcard masks. Y'all know what wildcard masks are, right? It's basically the inverse of a subnet mask. The subnet mask tells you what part of an IP address is the host network, and the other part is the net. One is the host, the other side is the network. I hope I'm explaining that right. I'm trying to figure out another way to explain that. The host is so let's give you an example for any newbies that are in here that don't know the difference between the two, right? We said this guy right here is 192.168.2.2. So that's the host address. That's the host address. But his subnet mask is probably /24, right? If they did it like how we should, right? Let's check the addressing guy, right? Host E, 2.2. His subnet mask right there is 255.255.255.0, right? Insider notation, that's /24. But the inverse of that would be 0.0.0.255. What is that? That is the wildcard mask. Again, the subnet mask tells you what part of it is the network, and then what part of it is the host, the actual host address. Right? I hope I explained that correctly. Y'all know I try to break things down in a more simpler language, but I try to explain as best I can. Anderson Tech said, "It's all good, bro. You'll come back stronger." Man, I missed it. Oh, it's all good, man. It's all good. If you seen that one video and you liked it, you subscribed, and you put in on the comments of that video, then you would have, entered threw your hat in the ring to join the raffle, but somebody else won, so it's all good though. Where were we? We were on task 2. Examine the EIGRP configuration on all 5 routers. How many EIGRP autonomous systems are present in a network? Well, first of all, what's an AS, or autonomous system? Autonomous system is a group of routers, or it's the, how do I say? I like to call it the, kind of like the neighborhood of EIGRP. So let's look at what it is first. I'll give you an example. Let's say we put just these 2 guys in a specific AS, right? That would be called the autonomous system, right? We can put these guys in a separate process of EIGRP. That would be another autonomous system, which, by the way, BGP kind of works similarly, right? So we have 2 ASs in this case, right? And we do it from a number from 1 to, I believe, 65, 535, right? Any number, right? And that, yeah, that would be the AS number, right? And then, so we can have, like, I don't know, AS 500 here, and we can have 50 there, and maybe AS number 60 there, right? So we got 2 different ASs. They want us to check each of these routers and see what ASs are they in. Let's start with Miami. Let's start off with Miami. Let's go down south real quick, right? 305, take it to the house, 305. It even tells us right there. If we look at that message right there, but let's verify that, right? Verify our work. Cisco, no. It was admin, enable. I believe the password was Cisco. We do a show. The way we can verify that is there's several commands we can use to verify the AS number. My favorite is show IP protocols. And we scroll up, we'll see EIGRP protocol is EIGRP 100. But that doesn't say in plain English what the AS is. I just kind of know it, right? But if we say, let's say show IP, what's another way to do this? To find out the AS number. Show IP protocols is one way. We could say show IP interfaces, EIGRP. No, show IP EIGRP interfaces. No, that doesn't tell us. Yes, it is right there for AS 100. That's one way to tell us. So that actually tells you in plain English, AS 100 right there. There's probably another way too, but that's the 2 I think are probably the best. We don't want to go through every single command. Go to Daytona. Let's see what his is. It even tells you right there too, 100 as well. But let's verify our work. Enable Cisco show IP EIGRP interfaces. AS number 100. Let's go to Orlando, or the city I'm actually at. Come on, man. Wake up. Admin. Enable. Cisco. Show IP. Let's do protocols this time. EIGRP 100. And I'm pretty sure that's 100 as well. Let's go ahead and check anyway, right? Admin. Come on, man. Come on, man. Come on, Vlad. He said, I did a video on it. Y'all check out Professor Black Ops. He has all the stuff in cybersecurity, man. The government agencies get a continuous application program with about 10,000 findings to fix. Whew. They get about 1 year to show improvement and got people demoted and fired. That is crazy. Wow. So yeah, you really got to know the security stuff, man. Yeah, I kind of did something very similar. I'm in charge of the like pretty much the layer 2 infrastructure at my job, right? And a couple specific subnets, and they found a couple vulnerabilities in mine. It was like, this is what you got to fix. And yeah, so that was pretty much my project. I had to find those holes, and then pretty much conjure up a report and be like, hey, look, boss, this is what the firm found in our network. This is how I did to fix it. I don't know if we're gonna send another one, like have them come back and see if we actually fixed it. I don't know how. I'm not part. That's beyond my pay grade. But I had to pretty much fix those problems there. So, what we said the password was Cisco, admin, enable Cisco. Let's race through this, man. Cisco, come on, Cisco, show IP protocols, and it is Eigrp 100. So yeah, they're all participating in Eigrp 100, and so is Key West. So next thing they want to know is what commands should be issued on all 5 routers to specify the interfaces that should attempt to form Eigrp neighbor relationships. I believe it should be Eigrp show IP Eigrp interfaces. That's what I think. Because if you look at the keywords here, right? Interface, Eigrp, what should be command that should attempt to form? We know it's going to be a show command. That's what I think. And if you don't know the answer to that, you can go to solution guide at the bottom, right? So we go to task 2, question number 3. Task 2, where we at? Task 2, question 3. The network command should be issued on all 5 to, oh, see, I was wrong. It should be issued on all 5 routers to specify the router interfaces. Oh, I was thinking of something else. So yeah, we need the network command. See, I'm glad we looked at the solution guy, right? Ain't no shame in my game. So we need a network command to put specific interface, just like we did in the last lab. We use the network command to say who should participate in the Eigrp. I read that question wrong, I guess. What's understand wildcard mask, which I kind of explained earlier. The network commands in the router Eigrp configuration of each router identify the interfaces that will participate in the Eigrp routing topology. In the initial configuration for this lab, the network commands include only the classful network addresses, right? Remember, we have 3 classes, the A, B, and C. And classful meaning either the 192 network is class C, and I believe like the 10 network is class A, etc., right? This limits the flexibility of assigning interfaces to the Eigrp process. Briefly explain why this is so. Just like I was saying, the 192 is strictly for class C, 172 is class B, and the 10 network is class A. Describe the main difference between wildcard masks and subnet masks. We did that earlier. I said the subnet masks tell you what part of the network is the host address and what part of the network is the network address, right? So if we have, let's say, this right here, this address right here, 192.168.100.0, how do we know what part of the address is the host, or the actual, like the actual computer or the router, the actual address, and what part of it lets you know what network it is in? Well, the subnet mask tells us that, but the wildcard mask is the inverse of that, right? So this limits, yeah, that's basically we explained it here. So explain how Eigrp would select interfaces if it were configured with the network 192.168.100.0 000.255 command. So when we see these zeros here, we're saying we don't care what part of, we don't care, like Stephen A. Smith says. Part of the address is we don't care what part of the what numbers you got there. But this last, no, it's the other way around. What am I thinking? Yes, it is that. We care, we want this to be the exact number. But this last number right here, we do not care. Whereas the subnet mask is the opposite of that. I hope that explained that right. So when we're saying this first octet, match it. So we want it to say, we want it to be exactly 192. This next octet has 0. It needs to say 168. This last octet is also 0. It needs to be in the 192.168.100 network. This last octet right here, we don't care. That's why we put a 255 there. So when we want to select interfaces, the interfaces must match these first 3 octets here. That's what this wildcard mask tells us. I hope I explained that right. If I didn't, put it in the chat, and then I'll try to explain it again. Just ask away. There's no such thing as a stupid question. I just try to explain it as best as I can. That's pretty much why I started a YouTube channel. C. So is this the last task? No, we got one more task. Implement Eigrp wildcard mask. Examine the configuration of each of the 5 routers in the topology. How many network commands do you see listed in the Eigrp configuration of each router? Let's start off with Miami again. I love Miami. Close this guy. Work stuff here. They said to look at the routing configuration for Eigrp. Best way we do that is show run pipe section Eigrp. That lets us know how Eigrp is configured. We have here classical networks of 192.168.3.0, 100.0 with no subnet mask there, right? So we're auto summarizing there, but being that these are the class full networks, we know that the subnet mask should be /24 because these are class C networks, right? You have to kind of know the subnetting fundamentals to know that. I don't want to get too deep, otherwise this will turn into a 3-hour video. So, but these are class C networks, so that means it's a given that these are /24, right? With wildcard masks, we add more flexibility by doing that. Let's go to Daytona and see what his says. Show, run, pipe, section, Eigrp. Same thing here. We got 2 network statements there. Let's go to Orlando. Let's use another command to look at the configuration. Show. We could do show to look at the configuration for Eigrp. You could do show run and then section. My bad. Pipe section router is another one. That tells you all the routing protocols. Well, we only have one on here. Pretty much same thing. We have a network statement for that network statement for that network. I'm not gonna check all 5. They're pretty much set up similarly. So reconfigure Eigrp on each router so that a single network command can be issued to specify all interfaces that will run Eigrp. So let's start off with Miami. We need a interface that's going to match both of these. I mean, a network command that's going to match both of these. We said there's /24, so let's match. Since we don't care about this last interface, we could do /24 and do .o, but these two are different. So we know that these two match. So let's make sure that we have a network statement to make sure that the first 2 octet match. We don't care about the last 2 octets. So in this case, we'll go to global config mode, router Eigrp. We said the AS number is 100. A network statement would be 192.168.0.0. And when I first thought about this, I thought, why don't we could just match all the interfaces and use 0.0.0.0. Well, if we do that with all routers, we'll create a black hole, because we're saying send all of our traffic here or to the next interface, and all the other routers will do the same thing, and it will just create a loop. So that ain't gonna work. We're using this network statement here, 192.168.0.0. I guess I could have pop quizzed y'all. He said you're doing as well. We appreciate what you're doing as well, Professor Black Ops. I tune in your channel as much as I can. Yep, I sure do too. He said, we got Jason in the building. Appreciate you for tuning in. Good to see you streaming again. Yeah, man. I said I'm going to try to pick back up on this. I ain't going to say I got more free time, but y'all should have seen yesterday when I started my stream on a Sunday. And I had my boss calling me up and was like, hey, we need to get this done. There's like this huge event that's going on. And I had to pretty much log on and work on it. So that's how busy I've been. Right when I started my stream, you could play back my channel. You'll see I got a phone call on a Sunday. I do it for the whole .org, networking, programming, Windows, Linux, database, firewall, load balancing, policies, data centers, etc. Yeah, that's crazy. So yeah, y'all know y'all tune into Professor Black Ops' channel, man. He's really in tune with the cybersecurity field, and he knows a lot about security. He's got about 30 years of experience. 30 years of experience in the IT field, in cybersecurity all together, security in general. But yeah, he knows his stuff. So we said we want to mask the first 2 octets. So that means the wildcard mask is the subnet mask. We know will be 255.255.0.0 if we did it that way. We're saying to match these first 2 octets. The last 2 we don't care. We just want to make sure that the first 2 octets match. Anything that matches with these 2 octets, have it participate in Eigrp. But we don't work with subnet masks. We could, but we're going to work with wildcard masks, since that's what the lab called for. In this case, it's the inverse of a subnet mask. So 00.255.255, right? Press enter. That should, we need to remove the other network statements. That's what we should do. Let's remove those guys right there. 3.0 and 100.0. No network, because they said reconfigure. So 192.168.100.0. That is a typo. 168. I'm glad I caught myself there because I would have got stuck. Y'all seen how I fudged up a couple streams before doing that. The other network was what? 3.0 network. We getting rid of that one. So 3.0. And let's take a look at our config now. Show run pipe section Eigrp. That looks a bit better. Yeah, let's do the same thing for Daytona, Orlando, and Tampa, and Key West. So we're going to get rid of these two network statements, combine it with one network statement that's going to match both of these networks. Global config, wash, rinse, repeat. Router Eigrp 100, no network 192.168.4.0, and get rid of the other one, which is 100.0. This should actually tear down Eigrp once we do this. As you can see right there, interface down, because we don't have a network statement. That's going to make these interfaces, make these two interfaces right over here, that one and that one, to participate in Eigrp. We're going to add one now. So network 192.168. Y'all hit me with that like button. We said 0.0, subnet mask of 0.0.255.255. That brings up Eigrp again. Let's do the same thing on Orlando, Tampa, and Key West. Interface said goodbye. I feel like I've done this lab before. Have I? I don't know. I done these labs so many times. Or maybe I done one similar. Because I remember there was a lab that had the cities and stuff. Show run. Oh, we already did it right there. These are the networks we need to get rid of and combine it with one network statement. So let's go to global config mode. So the 1.0 network and 100.0. Router Eigrp 100. No network 192.168.1.0. Oops, 1.0 and 100.0, 00.0. That should tear it down. Add a network statement that's going to do 192.168.100. No, we said 0.0. And then the subnet mask of 0.0.255.255. Damn, I did it wrong. .255. That was I pressed enter there. That should bring back the neighbor relationship again. Let's see. Yep, there it is right there. Go to Tampa. Do the same thing. Come on, man. We almost done here, y'all. Go to global config mode. Router Eigrp 100. No network. What networks do we have in here? The 2.0 network and the 100.0 network. Y'all see the show IP protocols tells us the networks. 192.168.2.0. Get rid of the other one, which was 100.0. Is that the 100.0 network? Yeah, I guess so. 100.0. That should tear it down. Add the network statement of 192.168.0.0. Subnet mask of 0.0.255.255. That should bring it back up. Wait for it. Wait for it. Looks like we messed something up there. There it is right there. Came back up. Had me nervous there for a second. Let's go to router Key West and do the same thing. What networks are we advertising for? It looks like 5.0 and 100.0. Let's verify that with show IP protocols this time instead of. It's always good to vary your show commands. Don't try to run the same ones all the time. 5.0 network and 100.0 network. We need to get rid of those. Router Eigrp 100. No network. 192.168.100.0. And the other one was the 5.0 network. 5.0 network. And we're almost done here, y'all. Network 192.168.0.0, 0.2, no, it's 00, my bad, 255.255, and that should bring up a neighbor relationship again. We good to go there. Let's show IP route this time, and notice our routing table looks a lot smaller, but it looks like we don't have any Eigrp routes. What the hell happened there? Let's run that. Y'all see how quick I ran that routing table, and we only see connected and local routes. Let's see what happens if I run it again. Now I have the D there that has the Eigrp route now this time, right? Summary route. But when we did it last time, I did it so quick that time. Because remember, Eigrp has to calculate the routes and stuff like that, figure out the best way, and then it adds it to the routing table. What was the next step they wanted us to do there? We reconfigured Eigrp. What would happen if you issued the router Eigrp command with an AS number other than 100 without removing the other one first? Well, you're just going to create another routing process, and that's pretty much it. It ain't going to break nothing. You're just going to add another routing process or another AS. Remember what I said AS is? It's like kind of like a group of routers, or yeah, kind of like a group of routers or neighborhood. I don't know another way to explain that. Task 3, verify Eigrp wildcard masks. Display the Key West routing table, which we just did. I ran it the first time. We only saw connected and local routes. I ran it again, and this time I see an Eigrp route. What do they want to know now? Refer to the network topology diagram and output the Key West routing table. Are all networks shown in the topology either directly connected routes or Eigrp routes? Well, all. So we have all these directly connected routes, and then for the other ones, we just have a direct Eigrp route that takes us to all the other routes. If that makes any sense. Compare this output to the results you previously received. Has anything changed as a result of implementing Eigrp wildcard masks? Well, let's look at when we first ran the show IP route command. When we scroll up in the earlier part of this stream, we did show IP route, and this is what the routing table looked like. It looked like a hot mess. You know, we got these individual routes that took us to these individual networks, and it just made it convoluted, man. Y'all see that? Right? We have ways to get there, but it just made it, I don't want to say more confusing, but how do I say this? I don't want to say less efficient either. Yeah, it could be less efficient. It puts more overhead on the router, so it causes the CPU to think, okay, how do I get to the 4 network? How did I get to the 5 network? Well, I got a way to get there to here. But when we used wildcard masks, we took all this shit right here and put it into one concise table, which made it a summary route, which we can see now it just looks like this. So now we have shit, man. Hold on. Let me not press it again. We just took to get to the 192.168 network, we have this to tell us that. It even says right there is a summary. So it made the routing table more concise. Again, less overhead on the CPU of the router. We compared to the verify connectivity from host A, attempt to ping host from host E, attempt to ping host A, B, C, D, etc. All these pings successful. So we got to go to host E, this guy right here. They want us to go to that guy right there. Boop, this guy, and have him ping this guy, have him ping that guy, have him ping this guy, and have him ping that guy right there. He might not take that route. He might go over there using this way. Depends on how Eigrp calculates. But let's start off with pinging. Let's go to host E and ping host A. Let's try to do that first. Host E. He said 2.2. Already have it in the cache there. Press enter. We're waiting. Not reachable. So something broken. We don't have a way to get there. We're missing something here. Let's try it again. Unreachable. Something fucked up there. So we could figure out what's going on here by pressing Control G or go to lab and then grade lab to figure out what's wrong. But let's try to fix what's broken here. We're at the tail end of the stream, but we need to figure out what's wrong. He don't know how to get there. Why not? Well, first of all, does he have a way to get to the 5 network using Key West? Let's see. Show IP routes. Let's say 192.168.5.2. Does he have a way to get there? Yes, he said the 5.0 network, which lies off of this right here. That's interface right here, right? The 5.0 network, which is right in 5.0 network. 5.0 network is that right there. Oh, you know what? Was I on host A? Let me make sure I was on host A. Let me make sure I was on host A. It looked like I was on host E. I meant to do... What was the question? What was the question? Real quick. Host E, ping host A. Yeah, so from host E, I'm supposed to ping host A, that guy right there, which is 192.168.2.2. Yeah, and that didn't work. So we got a reply from 5.2, which is, I believe, our gateway. Right? Let's verify that. 5.2. No, he said 5.1. We got a reply. We got a reply from 5.2. Who is 5.2? Let's see. Show IP routes. We don't have a way to get there. 5.1. Let's do this. 5.1. Lies off of that. Can I ping 5.1? First of all, let's see if we can ping our gateway. Host E. Let's see if he can ping 5.1. 5.1. Yes, we got a reply. No, we do not. Yes, we do have a reply to the gateway. I was about to say 5.1, which lies off of that guy right there. Yes, he can ping the gateway. Can he ping Miami? Let's see. Show IP interface brief. Can he ping 3.1? Let's see if host E can ping 3.1. Got to figure out what's wrong here. 3.1. Y'all see what's wrong? Anybody see what's wrong yet? And no, this is not a cliffhanger or I'm trying to quiz y'all. I actually broke it here. We can't ping. Yes. No, we can't ping 3.1. Why do we not have a route to the 3 network? Let's see. Key West. We probably did not put. Did we put the did we fix the neighbor statement here? 192.168 5.0. Let's see. Let's look at our. Oh, jeez. 192. Let's do this. 192.168.2.2 because I don't know how to break it on here. No reply. What is going on here? So Control Z. Let's get out of that. I can't get out of that. There we go. All right. Show IP route. Does he know how to get to the 5. Can he ping host A, which is 2.2? Ping 192.168.2.2. See, he can't ping 2.2. That's an issue. Let's make sure Tampa has. We got rid of the 2.2 network there. We gave him a 192.168.0.255. So those match. Show IP route. Let's see. 2.0 network. No problem. Cool. Yeah, I don't know. I'm trying to figure it out here. Again, we could always just grade lab and it'll tell us the answers. But let's try to fix this without that first. What we do on here? So host A can ping Key West. He can ping Miami, right? Can he ping the local interface right there? Where's Miami? Miami was that fast interface was 3.1. Can he ping 3.1? He cannot. So something wrong, something is broken right in here. Does Key West have an EIGRP neighbor relationship there? Show IP EIGRP neighbors. He does. Does this guy have neighbor relationship with all of them? Show IP EIGRP neighbors. He only has neighbor relationship with 3 routers. Which is this guy, that guy, and that guy, right? Let's see. He has one that's off the 2 serial interfaces, but he does not have a relationship with the 4th serial interface. Oh no, that should be it. That's all should be it. That's just those three. He has a neighbor with this guy, a neighbor with that guy, and a neighbor with that guy. So that's it. He should have just 3 neighbor relationships. But let's see. Does he have 3? He should have 1, 2 neighbors. This guy right here. He should have 2 neighbors. Show IP EIGRP neighbors. He has 2 neighbors. Do y'all see? He said Key West show CDP neighbors command. We'll do that too. Let's do that. Key West can't hit Miami. He can't? Let's see. I thought he could. Miami was 3.1. He can't ping 3. Miami, what was Miami? Miami lies off of the FA00 interface. So he can't ping 192.168.100.18 is what we're saying. Let's see. The fast Ethernet is 100.17. So Key West can't ping that is what you're saying. Ping. And I like this. I like the help you guys are giving me here. 192.168.100.17. Key West can ping the local interface there. So we got that. Can he ping this remote network back here though? That's the question. Which is off of Miami. Can he ping 100.14 and 100.10? Yeah, 100.14, 100.10. The serial interface is there. 100.14 and 100.10. Let's see. Can he ping 100.14? No, he can't. Ah ha ha ha. He can't ping 100.14. So yeah, you're right about that, Jason. Why is that though? Can he ping the other one? 100. What was the other interface? 100.10. 100.10. Nope, he can't ping that either. So there's something with Miami. Let's see. What does his neighbor statement look like? Or his EIGRP statement look like? Section EIGRP. That network statement looked good to me. Should we turn off auto summary? No. Why can't he do that? I'm about to just Control G and take a look at it. But we're on the right path here, for lack of better words. He wants to know about show CDP neighbors. What you want to know about it? Key West, can he see his CDP neighbors? Now we're going to layer 2 now. But I'm pretty sure show CDP neighbors, he sees Miami as a neighbor. Key West sees Miami as a neighbor, which lies off of FA01. But he just can't ping those 2 remote networks back there. This network statement looked fine to me. 192.168.0.0. Subnet mask of a wildcard mask of 0.0.255.255. Is that right? It's not 255.0.0, 255.255.00. No, we're working with wildcard mask. So let's take a look at. Let's see if we missed a step here. We have a summary route. I don't know if we needed a summary route. Let's look at Miami's routing table. Show IP routes. He has all of these. That don't. I thought we made those routes a little smaller. Did I not do that? Did I not put the routing? Let me take a look at his EIG. Let's look at both Key West and Miami's EIGRP configuration. Show, run, section, EIGRP. 192.168.0.0, 0.0.255.255. The same thing with Miami. We did that already too. Yeah, I sure did. 255.255. Yeah, that looks fine to me. What are we missing? We're at the tail of this stream. We're right at the finish line here. I don't think we should have done a /24. I think this was a good network statement. That looked fine to me. But let's Control G and take a look, so that way we can just end the stream. It says we completed the lab successfully. That don't seem right. Look at that. See? No, we're missing something here. Because obviously, were we able to ping? Maybe it needed a time to converge? Nah, it's quicker than that. Can host E ping host A, which was 2.2? Right? 2.2? It says unreachable. And then it said that we completed the lab. That don't seem right. That don't seem right. Something is weird here. Can host A ping, let's do it the other way around. Host A ping host E. What is the address? Did I type it right? 192.168.2.2. Yeah, he can't ping 3.1. Something is weird here, man. Let's see. What was the question again? Go back. From host E, attempt to ping these other guys. 4.2, 3.2, etc. Let's see if we can ping 4.2. And then we'll go in the yeah, see, he can't. Oh, he can ping 5.2. That's weird. So host E can ping 5.2. Who was 5.2? 5.2 is... Oh, that's myself. What the hell? He's 5.2. I'm pinging myself. What we need to do? Let's try to do 4.2. Let's see if we can ping 4.2. Which I think we tried already. Did we? No, we didn't. 4.2. Unreachable. See? Something is wrong here, but let's I'm gonna look at that guide again, man, because it says we got it all right, but we're missing something here. Oh, we got to get rid of that auto summary. That's probably why. That's what's breaking it. We need to get rid of that auto summary, and it should work. It should work. Let's have Miami. Let's get rid of that. That's what it is. Router Eigrp. Because notice notice it highlighted. I'll show y'all real quick. It highlighted it in blue. This command here, it says this is an extra command. You didn't need that. But that was already in there in the previous configuration. I just forgot to take it out. So I should have done that because we're not auto summarizing. We have a network statement that's gonna actually take us to where we need to go. So router Eigrp 100, no auto summary. That should bring down Eigrp and bring it back up. We did it in Miami. We probably should do it on the rest of them too. Go to global config mode, router Eigrp 100, no auto summary. Brings it down, brings it back up. Let's see if host E can ping 2.2. Pinging. Unreachable. Still not reachable. So let's do the same thing with the rest of these guys. Maybe Key West. I didn't remove it from Key West, did I? No, I didn't. Go to global config mode, router Eigrp 100, no auto summary. See, I need to study for sure that auto summary command in depth. And let's see if we can ping 2.2 now. Unreachable still. Maybe we got to do it. Who else we need to do that on? Oh, we just got a reply. We finally got a reply right there. Let's try it again. 2.2. Now it's reachable. We needed to get rid of that auto summary command. That's crazy. Y'all see that? What I should have done was just remove the Eigrp configuration altogether and then put that network statement there. I left that auto summary command there. I need to look in depth tonight what it actually does. And that you see, we left it there and it broke it didn't break the lab, but it caused the routing to not work. So y'all hit me with that like button, man. That's what I like about Boson Netsim. If you kind of get stuck, it'll at least, tell you what went wrong. It said we completed the lab successfully, but obviously we didn't because we couldn't ping across and stuff like that. So that's the kind of drawbacks with this. It's smart, but it ain't that smart. I think that's pretty much it we're gonna do tonight. Just these two labs. Tomorrow, am I gonna lab tomorrow? I'm not gonna be streaming very often on Mondays because Mondays I started a basketball league. I joined one for the local Y over here, and the games are on Mondays. So I don't think I'm gonna be streaming on Mondays. Maybe I will. It depends on what time the games are, because it's like anywhere between 5, like around the time after work and stuff like that. So work-life balance, man. I love this networking stuff and stuff like that, but ball is life. So tomorrow, if we do have time, yeah, we'll stream tomorrow. We'll go to where we at? View. Where we at? The windows. The labs. Which lab did we do? It wasn't a CCNA. It was not Encore. It was an RC. We did these 3 labs right here with the green check marks. So tomorrow, configuring Eigrp part 1. We'll do that lab. So if you have a copy of Boson Netsim, kind of go over this, or if you have a copy of the official cert guide, kind of refresh Eigrp. We'll go over this right here, part 1. We'll probably just do that lab because it looks pretty lengthy, and then we'll do part 2 next day maybe, and then we'll just keep going. So it looks like we got a lot of Eigrp labs. For now, comment, like, subscribe to the network. Oh, wait. Dave said, how big of a difference is Netsim to Packet Tracer? Good question. Packet Tracer has way more devices, so like wireless controllers, access points, and stuff like that. Boson Netsim just focuses strictly on routers and switches, and maybe some end devices and stuff like that. What else? Packet Tracer is much more limited with its commands. There's way more commands and support with Boson Netsim. It's a much more controlled environment. They both have a grading feature. What else could we say? Packet Tracer has a much more larger community, so there's more people creating Packet Tracer labs than there are Boson Netsim. Packet Tracer does not have like labs that are kind of like set up in order like this for you, so that from all the way from basic command line stuff all the way down to really advanced ACLs and BGP labs, all the way down to the more complex networking topics and stuff like that. So they don't, you got to kind of find labs with Packet Tracer or make them up on your own. Boson Netsim, you can kind of make your own labs too. I haven't figured that out, but there's also a community tab here, and you can see labs that other people created. See, as this guy right here, Jan Back Jr. created that lab. You can download it. You can do that with EvenG too. There's a large EvenG community. There's a large GNS3 community of people creating their own labs, and you can kind of practice there, or just build them on your own. What's another difference? Cisco Packet Tracer is a Cisco proprietary. Boson Netsim is just done by this company called Boson. What else? Daniel Lopez, shout out to you. Appreciate you for tuning in. He said, appreciate the stream, brother. Did some labs today and saw you were streaming and logged on. Keep up the good work, man. Appreciate you for tuning in, man. I thank all you guys for tuning in, man. We got Kobe in the building. Appreciate you for tuning in as well. But yeah, that'll be in tonight's stream. I usually try to get it done at an hour. We did about an hour and a half streaming today. So I'll try to stream again tomorrow at 8 o'clock. For now, comment, like, subscribe to the network.